Welcome to CE202 material sessional. Today we are going to show you the procedure of experiment number 3, determination of compressive strength of hydraulic cement mortars. We will be using a water cement ratio of 0.485 and cement to sand ratio 1:2.75. We will be making 3 specimens from a batch of mortar for each period of test, that is 9 cube specimens. As you can see from the video, we are taking about 700 gram of cement to prepare our cement mortar cubes. The sand used in this experiment is Ottawa sand having a gradation as per specification of C778. Now we are taking about 1925 gram of sand for the mixture. Lastly, 339.5 gram of water is taken for mixing the cement mixture. The temperature of the water is 22.2 degrees Celsius, which conforms the requirements. Now we are placing the dry paddle in the mixing position of the mixer. After placing the dry paddle, we are taking the cement and the water to the mixing bowl and placing it to the mixing position of the mixture. Now we have start the mixture and we are mixing at slow speed for 30 seconds. In the meantime, we are adding the entire quantity of the sand into the top feed of the mixing machine so that it can be added to the mixer over a 30-second period of time. After mixing this at slow speed for 30 seconds, we have to mix it for another 30 seconds at medium speed, and after 60 seconds, we have to stop the mixture and let the mortar stand for 90 seconds. During the first 15 seconds of this interval, we have to quickly scrape down any mortar that may have collected on the side of the bowl. After the 90 seconds of rest, we have to finish the mixing within 1 minute by rotating it at medium speed. This is the mold used for preparing 2-inch cubes. We will be using 3 molds for preparing 9 cubes required for our experiment. We have to brush oils to the surface of the mold so that the cubes can be easily removed from the mold. We have to start molding the specimens within 2.5 minutes after completion of the original mixing of the mortar batch. We have to place a layer of mortar about 1 inch in all of the cube compartments. We have to temp the mortar with temper in each cube compartments 32 times in about 10 seconds in 4 rounds as shown in the video. Each round has to be at right angles to the other and consists of 8 adjoining strokes over the surface of the specimen as illustrated in the figure at the lower right corner of the screen. The tamping pressure should be just sufficient to ensure uniform filling of the molds. We have to complete the 4 rounds of tamping, that is 32 strokes of the mortar in one before going to the next. Similarly, all 3 of the compartments should be tamped with the tamping rod in the same way. When the tamping of the first layer in all of the cube compartments is completed, we have to fill the compartments with the remaining mortar and then tamp as specified for the first layer. During tamping of the second layer, we have to bring in the mortar forced out onto the tops of the molds after each round of tamping with gloved fingers and the tamper after completion of each round and before starting the next round of tamping. We have to bring in the mortar that has been forced out onto the tops of the mold with a trowel and smooth off the cubes by drawing the flat side of the trowel. Then, for the purpose of leveling the mortar, we have to draw the flat side of the trowel lightly once along the length of the mold. We have to cut off the mortar to a plain surface flush with the top of the mold by drawing the straight edge of the trowel. Immediately upon completion of molding, we have to place the test specimen in the moist room for 24 hours with their upper surfaces exposed to the moist air but protected from getting wet through water. As you can see from the video, this is how we demold the cube specimens from the mold. Load is applied to the plain surfaces which were in contact with the mold surface, and we have to mark the specimens according to their casting date. We have to immerse the specimens after demolding in saturated lime water in storage tanks constructed of non-corroding materials. This process is called curing of the specimens. After removing a specimen from water for testing, we have to wipe each specimen to a surface dry condition and remove any looser sand grains from the cube face. Then we have to measure the critical cross section dimensions to the nearest 0.01 inches prior to testing. This is the compression testing machine used for our experiment. We have to carefully place the specimen in the testing machine below the center of the upper bearing block. Now we are applying the load. As you can see from the video, the maximum load indicated by the testing machine is 47.428 kilonewton. As you can see from the video, the specimen has failed at this maximum load. We have to convert this observed load to actual load using this calibration equation on the calibration chart. We have to repeat this procedure for the other two cube specimens. Similarly, we will test 3 specimens after 7 days and the other 3 specimens after 28 days. Here in the video, you can see the test results for 3, 7 and 28 days. That's all for today. Thank you everyone for watching.